Let's now look at a confidence interval for a difference of proportions. We have some data here that represent seatbelt use in Boston and New York, and we're interested in the population parameters. P sub ny is the proportion of female Hispanic drivers in New York who wear seatbelts. I should mention the data actually represent female Hispanic drivers, which is why we're extending to the population of female Hispanic drivers. And P sub b is the proportion of female Hispanic drivers in Boston who wear seatbelts. So the statistics we can use to estimate these we would call P sub ny hat, and it's going to be the total belted in New York over the total drivers in New York. So belted in New York is 183, and total in New York is 220. And we can calculate this proportion as 0.83. And then P sub b hat is belted in Boston. Sounds kind of like the title of a reality show. Belted in Boston over total drivers in Boston, 117. And then we've got 0.58. So just looking at these sample statistics, it does look like there's enough of a difference here that we're inclined to investigate. They seem pretty different. One thing that we'll get into more in the next chapter when we get into hypothesis tests is this the kind of difference that could be due to just the luck of the draw? If you were to take a sample of drivers in any two cities, even if there's no real difference in behaviors, you don't expect to get the exact same proportion in your sample. So is this the kind of difference that could be due to random chance, or is this a sign that behaviors are different in these two cities? So right now we're just going to estimate the difference with a confidence interval. And we're going to do this in StatKey. So we will go to, this time, Bootstrap confidence intervals, CI for difference in proportions. And then when we click on Edit Data, we'll see that we have a little box for each one of these numbers. So we want to think about which one is New York and which one is Boston. We are defining group 1 to be New York and defining group 2 to be Boston. One nice thing about proportions is that you get to control that. A lot of the time when you're pulling in a data set, StatKey just decides which one is group 1 and which one is group 2, usually just based on which value comes up first in the data set, and you don't have any control over it, and you have to interpret whatever direction it decided to subtract in. So we get to tell it New York minus Boston, which is kind of nice. So in StatKey now, Bootstrap confidence intervals, CI for a difference in proportions, then clicking on Edit Data and entering these values: 183, 220, 88, 117. I'm sorry, I think that's 68. Yeah, 68 and 117. So that we can see our difference of proportions. So the summary statistics are given under original sample. Group 1 minus group 2, that proportion in the corner is our difference in proportions, 0.251. That should be the same thing that we would get if we were to subtract our two values, although it's carried out to another decimal place. So P sub ny hat minus P sub b hat is equal to 0.251. Now we'll generate a few thousand Bootstrap samples and find a confidence interval using percentiles. I like to watch my standard error, and when it looks like it's not changing very much, I go ahead and stop. Sometimes it takes a long time to stabilize, and if you get all the way to 10,000 samples, just stop. But in this case, it seemed to stabilize at about 2,000 or 3,000. So I need a 99% confidence interval, which means I'm going to change this middle proportion from 0.95 to 0.99. And my confidence interval comes from these two endpoints. I shouldn't have actually clicked on that. I was just trying to call attention to it. 0.114 up to 0.384 in my case. So this is plausible values for the parameter expression p sub ny minus p sub b. And what we notice about this confidence interval is that it is all positive. It doesn't have a negative left endpoint and a positive right endpoint. The whole set of plausible values for this difference is positive, which tells us that the proportion in New York is, with a very high level of confidence, higher than the proportion in Boston. So that's how we're going to answer this next question. It is not plausible that they're the same because the confidence interval does not include 0. So p sub ny minus p sub b equals 0 is not in the interval. Therefore, 0 is not a plausible value, and therefore we don't think they're the same. And furthermore, the fact that it's positive and that New York comes first in the subtraction also tells us that we believe the proportion is higher in New York. We believe the proportion in New York is higher by somewhere between 0.114 and 0.384, or by 11.4% and 38.4% if we were talking about percents rather than proportions.